Hello everyone, welcome back to the first new video in a while. I wanted to cover something that I've noticed has come up for debate in the Unity forums a couple of times, and I've been meaning to sort of try my hand at the interpretation of it, and that's a wrapping scrolling playing field. But I wanted to sort of do a little bit more and explain what that was, and by doing that, I was going to look at a couple of examples. That I could get my hands on at short notice. So these are the two examples I could get my hands on. So the first up is Defender. Well, actually, it's Defender 2 on the NES in this case. It was written by Eugene Jarvis, who would go on to write one of my favorite video games, which was Robotron 2084, as well as Narcs and Smash TV, which is so good in two-player mode. Really, really good. So the gameplay for Defender is simple. You have to save the little humans on the land from being kidnapped by aliens. If you fail and they're captured, they end up merging. The aliens take them up to the top of the screen, um, and they become mutants, and they're a menace to you because basically they move more erratically and much faster than their slower alien counterparts. And after Space Invaders, Defender really kind of added depth. There was more screens that you could scroll through. Because the world wrapped, it felt like you were part of a larger universe. It felt like the gameplay would go on forever. And in fact, it did because you just kept scrolling. And so in Defender, you also feel the weight of the craft as well as it moves from left to right. It does it so it gives you more room to see what's coming. So when you're heading right, the ship moves to the left most of the screen, and then when you head left, the inertia of the craft slows and then places you on the right and then speeds you up again. It feels so good, it feels so weighty. Um, the second is Drop Zone from Archer McLean, which was written by him on the original Atari 800, I think, but it was for the whole Atari 8-bit series of computers. But it was ported by himself to Commodore 64 and other systems. I'm not sure if he had a hand in the other ports or not. And it's the NES port that I'm playing just now. It has a number of similar features to Defender. You'll notice that it's got a similar feel. The scrolling world moves under your feet. The world wraps left to right. But where for me it falls down is that kind of feeling of inertia as you're, well, it's not a craft in this case. It's your little astronaut. Uh, he floats from left to right. He just does a turn, so he doesn't move from that center of the screen, and it kind of loses a bit of the weightiness for me. Anyway, how did they achieve this scrolling world, this scrolling wrapping world? Well, I thought we'd look at that in this video, and no better place to start than after the fade. So before we get started, you can download all the resources from the project if you go to github.com codehouse and then go to the world wrap shooter, and you can click on the releases tab. So if you go to here and then click on releases, you can download the release, which is version 0.0.1. It needed a tag, so I gave it that tag there, and download it from there. Links, of course, are in the show notes. And before you get started, don't forget to subscribe and hit that notification bell, and then you'll get timely reminders of when the next video is up. Okay, so I'm going to go ahead and create this project now. It's going to be 2D, and this is the position I'm going to call it there, and I'm going to put it inside World Wrap Shooter. So I'm just going to hit this, and then we'll be back in a second once Unity gets around to building it. Okay, so now that that is done, what I'm going to do is uh, I have a background already done, which is 4 screens, and that's going to be the sort of size of the world, and then we're going to wrap it round. So in order to do that, we have to create the illusion of the wrap, and we're going to do that with a couple of cameras. There's probably a better way to do it, and if you have a better way to do it, put a note in the comments. But this is how I thought about doing it. And the way I'm going to do it is the background is going to be fixed, so it's going to we're not going to redraw. We're not going to clear the camera before we redraw the background because we're immediately going to splat sprite on top of it. So there's no point in redrawing in clearing the camera. And that's really it. So what's going to happen is that one of the camera, we're going to have a camera moving in like that, and then we have another camera over here that's trailing it. So when this gets to this point here, this camera is going to be in the picture on the right hand side. So it's going to look as if it's seamless. I'm not explaining it very well, but hopefully it'll become a bit more apparent when we start doing this. So I'm going to create an art folder here, and over here I have PNGs, and I'm going to drag, this is the resources, part of the resources, which is the screens here. The screens, I'm going to change that to 300, it's 1280, so 1280 divided by 4 is 320. So I want it to be, one unit is going to be 320 pixels. And then I'm going to click on apply. I want point as well, and I'll click on apply. Okay, and so that's going to be our screen, or that's going to be the backdrop of our screen. So if I drag and drop that there, that's going to create a sprite, which is at 0, 0, 0. But you'll see that when we look at it in the game, it's that. We don't want that. We want this to be one screen. So what I'm going to do is I'm going to take the main camera, and I'm going to change the size of it to better fit the screen. So you can see in the camera preview down here that it's going down to there. So it's roughly, what is that, 0.3? 29, 28. It's got to fill the screen. Okay, and if I move the camera along to about here, if I make it negative 1.5, you'll see that through the magic of math and the fact that I've worked this out before, it fits exactly in there because each one of these screens is 16 by 9. So when I look at the game view, you see that it's filling the entire viewport. And if you actually zoom down there, that camera, I don't know if you can see it, you can pick it up on the video here, but you can see these little white dots that represent the extremities of the camera view. You can see that it fits in that perfectly. Now, when we move left to right, if I move the camera left to right here, you see that we're passing through these different worlds. And the idea is, I'll show you with a dummy camera just now, actually. So if I do this to minus 1.5. So I want to do a couple of things here. I want to do, I don't want to clear it. I don't want to clear it. I also want to set the depth to -1. That's fine. So I'm going to create another camera here called left camera. And I'm going to set that to be -2, which is that there. And I'm going to move this camera over to here. And we've got our left camera here, which is, that's right, -1, target texture, -1, and then the game doesn't quite match up. Why is it not matching up? Is that too far maybe? Where's the main camera? Oh, it is. So I make that 2. There you go. So I don't know if you can see this. I know this is a bit kind of, but what's happening is it's taking the left part of this camera. So it's taking the left part of the main camera, and it's taking the right part of the left camera. And when you see it in game, it's as if the two worlds match. It's as if the two screens match up seamlessly, and that's what we're going to be building today. Is this left-right movement? yeah, so that's what we're going to do. So let's get cracking doing that then. So I'm going to move this camera out to here. So now game's going to look like that because it's not showing anything else. And I'm also going to create another camera as well called right camera. Okay. So I'm gonna cheat. I've actually got some scripts I've done before that I'm gonna reference here. Okay, let me just get this right. Okay. So for the camera movement, we're only going to be moving the main camera. That's all we're going to be doing. In fact, I'm going to split this up into several different scripts. So there's the main camera, which is controlled by the left and right, and then the vertical is controlled by another script, which is independent to the camera view. In fact, we're going to actually have 4 cameras in this, so it's going to be a little bit different to what we're used to. So I'm going to create a folder here called scripts. And inside here, I'm going to create a C# script called CamMove. And once that gets created, I am going to drag and drop it onto the main camera. And then I'm going to boot up that there. So I found that because we're working with multiple cameras, it's actually quite difficult to get everything in sync in one update. So I'm going to have a private member field called position, which is going to be the position of the camera. And I am going to do the update, do the input in the update. Then I'm going to use late update to mark the position of the camera, or to change the position of the camera. So I'm going to have private float z, private float to 3 position. Oh, private float vector. Wow, there you go. So z is going to be transform.position.z. So we need to remember what z position we're at because we're currently at -10, I think. Yeah, -10. I mean, we could hard code it to -10, but I mean, you might want to change it for various reasons. And the position is going to be transform position. Okay. And then the update, I'm just going to have present equals position. And then I'm going to go and get the inputs from the user. So horizontal input.get axis, horizontal, and then position is going to be whatever the. So I'm going to use a bit of math here. So the positive direction is right. So I'm going to take the right vector and I'm going to multiply it by the speed, which I haven't determined yet, and the horizontal value. So if it's negative, it's actually going to be negative right, so it's going to be left technically. So I'm going to say vector 3.right times horizontal times whatever speed is. Let's make speed 20. I don't know, something reasonable. Times time.delta time. So whatever delta time is. So keeping the frame rate consistent. And then I think that's all I want to do for that just now. And then inside the late update, I'm going to transform position equals position. Do I need the original Z? I'm wondering if I need to ever actually use it. Let me see if that works. Okay, so we go into here, and let's reset the camera back to minus 1.5. So minus 1.5, and then if you scroll that to there, it gets to 0.5, and then that's going to be, sorry, that's negative 0.5, then that's going to be 0.5, and so on. So the math is actually easier if you just play around with the numbers to start with, and yeah, okay. So I don't know where I was going with that thought, sorry. Okay, so if we move to the right here, you see that we moved out to there, and then we go back to 1, 2, 3, 4. So 20 seems a bit fast. So let's have a private float speed, and then let's make speed be something not as fast as that. So I'm going to say speed equals 5. So we'll just make it private for just now, and then see how the speed goes. I'm tempted to make that 1, just to be on the safe side. It's a bit herky-jerky. There's a definite clunk. Feels like every second it's going clunk, clunk, clunk. Might just because it's running in the editor. Oh, there's definitely. Well, I don't know if that's my graphics card, but there is some shearing. I don't know if you guys can pick that up on the video. I'm looking at the monitor there. I can pick that up. Whoa, that is freaky. Okay, let's make it 1 just now. Okay, so that's changing the. I don't know why I'm using present. Oh yeah. Present. Do I even need that? I don't know if I need that. Okay, so the leftmost extreme is negative 1.5, which means the most extreme is 1.5, which is right. So I want to clamp it into that position. I'm looking at the notes I've got here, and I've got left extreme and leftmost screen, and they're both the same value. So I don't know what I was thinking there. Like it doesn't. I'm just going to call it left and right in this one. Private float left equals negative 1.5. Private float right equals 1.5. And this is going to depend on how big your world is. So in my case, I've only got 4. And just the way that the math is worked out for this, that minus 1.5 is the extreme part of that. If your camera zoomed in, it's a different size. You use different size for the world. It's going to change those values. But that just so happens that it's going to be the size that I've got there. So now what we want is we also want public references to those cameras. So we want public camera. Do we want camera or transforms? I think we just want transforms. Transform left cam. Transform right cam. So we've got our left cam and our right cam. So at this point here in our update, we can get rid of this line here. And at this point in our update, what we want to do is we want to check and see if the position is greater than the left extreme, and if it is, then we want to set the position to be the offset from the rightmost side of the screen. because we want to basically wrap it. So if we move to this point here, we should actually be over on the right hand side of the 4 here, but we're not. So that's what this is going to do. So I'm going to say if position.x is less than left extreme, position equals new vector 3, right, comma, z. If position dot x is greater than right, position equals new vector 3 left 0 comma z. Okay, so this should be really clunky, but if I go all the way to the right, it should send me back to the left. So I'm in the 4th position here. So I'll go to 1, 2, 3, 4, 1, 2, 3, 4, 3, 2, 1, 4, 3, 2, 1. And you can see that we've got kind of rudimentary thing, but it is like really jarring. And then what do we got in here? Our late update, we want to then add these 2 cameras into the mix. And the way we're going to do that is we're going to say left camera cam dot position equals new vector 3 minus 4f 0 z plus transform dot position, and then right cam dot position equals new vector 3 4 0 z plus transform dot position, and that will put those cameras in the right position, and then that should fix everything. So if I go back to my main camera and then I move this up a little bit and I move my left cam over to here and I move my right cam over to here, what we should get now is we should get 1, 2, 3, 4. That didn't work. Okay. So that does not seem right. Oh, wait. The left extreme is going to be 2.5 because it's got to go beyond that. Oh, I'm an idiot. Okay. So if I get the main camera and I go and drag that, where are we? Minus 1.5. I can't see my camera. Okay, why? And then I move that to over here, which is about 2.5. So it's got to be 2.5. That's why I've done it that way. Okay. So I actually do use those two different. I do use 2 different values. So I've got left and right, and then I've got private float, and then left max equals minus 2.5, private float right max equals 2.5. So the left max is this one, and then we've got right max. And that should be right, shouldn't it? Is greater than that. I'm going to set it to the left. Yeah, okay. Okay. So now we should start on 1, which is right because we shouldn't move from 1. And if I move to left, 2, 3, 4, 1, 2, 3, 4, 1, scroll back to 4, and now we have a continuous carousel of worlds, as if it's a continuous world. Hey, take a little drink for celebration there. All right, I think that about does it for this video. But before we go, let's tidy this up a bit. So we want to make, let's get rid of this here. We want to, the Z position and the speed, and we want to make that public as well. It's good enough there. And we want that to be public. So I'm going to cheat. I'm going to do my old rectangular selection there. Change that all to public. And tooltip, the speed of the camera. Rightmost position. Actually, this is going to be the position of the leftmost screen from the perspective the camera. That's not right. That's not how you spell perspective. Of the camera. Okay. Actually, let me just grab that whole line there. And that's gonna be the rightmost. And then the leftmost position allowed by the camera in the world. And then the rightmost. And then this is going to be, oh dear, a little bit zealous with that one. The left trailing camera. Right leading camera. Okay, we don't need that. We know what update does. We know what start does. I don't think we need any more comments in there. Do we have any variables we don't use? Don't think we do. No, I think we're good. Now, the reason why I'm doing that is because it means that if you have a designer that comes in here and wants to tweak these values, let's say they have a bigger rate, they have a bigger size for the screen, so it's not 320 by 180 the screen, it's going to be, you know, I don't know, 920 by 1080. Then they're going to want to tweak these values depending where the position of the camera is, the size of the camera, all that kind of stuff. So by exposing these, it allows you to make this script a little bit better. And also, if you add tooltips, then people will actually get to see what those values mean. So it's always a good idea to do that. And there you go. There you have it. That's the first video in the side-scrolly, worldy, shootery, defendery, drop zoney type game that we're making. I hope you enjoyed this video. If you liked the video, please like it. If you didn't, thumbs down, but let me know in the comments below. Don't forget to check the show notes as well for links to external resources. And don't forget also to hit that subscribe and notification bell to get timely reminders of when the next video is going to be up. But until the next video, thank you very much for watching, and I will catch you in the next one. Goodbye.